Today we are doing lessons 7.1 and 7.2, adjacent, vertical, complementary, and supplementary angles. Our I can statement for today: I can identify vertical, adjacent, supplementary, and complementary angles, and I can use what I know about angles to find a missing angle measure. All right, so we're going to start by just looking at adjacent angles and vertical angles. That's the 7.1 lesson. So for adjacent angles, two angles are adjacent angles when they share a common side and they have the same vertex. Vertex means like the corner where those two meet. So for the example here, so here's an intersection with four different angles that are numbered 1 through 4. So they tell you over here 1 and 2 are adjacent, and that's because angle 1, which is this one right here, and angle 2, which is this one right here, have the same side. Adjacent angles have the same side. They're right next to each other, and they have the same side. Vertical angles. It says two angles are vertical angles when they are opposite angles formed by the intersection of two lines. Vertical angles are congruent angles, meaning they have the same measure. Congruent means that they're equal. So 1 and 3 are vertical angles. The two lines that make them are these two right here. A little tricky for me to trace exactly, right? Okay, so those are the two lines that make them. And then 1 and 3 are diagonal from each other. They do not share a common side. They only share this middle point, but they're made with the same two lines. So 1 and 3 are vertical angles, and that means that they have the same amount of degrees. If this is 100 degrees, this is 100 degrees. 4 and 2 are also vertical angles. They are made with the same two lines, but they're not touching. They're across from each other. So for our first type of problem, they're going to ask us to name adjacent angles and name vertical angles. So when we name an angle, we use an angle symbol that looks like this. Looks a little like our Lessian symbol. And then we have 3 letters that describe the points on our angle. And the middle letter needs to be the vertex or the corner of the angle. So 2 pairs of adjacent angles. Let's see, I'm going to start with this one right here. And then I'm just going to use the letters that are on it. So I have F, B, A, or I can name it A, B, F. It doesn't really matter. I guess I'm going to name it A, B, F. Then I need another angle that is adjacent to that one. It means it shares a common side. So let's see, if I do ABF, then another one that could be adjacent to it would be ABC. This is ABF. This is ABC. They have this side, AB, in common. On your adjacent angles, 2 of the 3 letters are going to be the same. It doesn't have to be the first 2. I chose it to be the first 2, but it doesn't have to be the first 2. So those are going to be adjacent angles. They share that common side. All right, now we're going to do a pair of vertical angles. Vertical angles, remember, are made with the same 2 lines, but they don't touch. They're across from each other. All right, so I'm going to erase my writing there. And I'm going to trace 2 lines that go all the way through kind of that middle point. ABC, oops, it's not ABC, sorry, FBC is a line, and ABD is on another line. Okay, and then I need 2 that are across from each other that are made of those 2 lines. So I'm going to do these 2. I'm going to use that ABF again. And CBD. I could have also named that DBC. It doesn't really matter the order of the letters as long as the middle point is the middle letter here. Here, the only letter they have in common is the letter B, but they're made with the same 2 straight lines. If I was going to do, I'm going to erase some of my writing here. Let's say I wanted to keep that ABC, and I said, well, I see that EBD They don't share a side. But if you look at these two angles, no, they're not adjacent. They don't share a side, but they're also not vertical. Because these two, this one's a straight line. This one is not a straight line. It goes like this. So you have to have ones for vertical that are made of two straight lines together. All right, let's go ahead and take a look at our next one here. Okay, so for the next type of problem, they're going to show you two angles, and then you're going to say adjacent or vertical, and then you're going to solve for the missing angle. So let's start with A. 70 and X are across from each other. They are not touching. They are made with the same two lines. So that's going to be vertical. And vertical angles mean that my degrees are going to be the same. They're going to be congruent. So if this one's 70 degrees, that one's 70 degrees. For this particular one, there isn't any work to show. If there's vertical angles, they're going to be the same. Now, if this was, say, x minus 2 equals 70, then I'd have to set up and solve an equation. But when you just have an x and you have the other number and it's vertical, there isn't really any work to show. Let's take a look at B. These two are next to each other. They share a side. This is the common side that they have right here. Those two are adjacent angles. Okay, so we know these two touch each other. That's what makes them adjacent. And then if you look closely, there's this little right angle here. That tells us, that square tells us that they're going to equal 90 degrees. That's what that little square is telling us. So because we know together they equal 90 degrees, we can set up and solve an equation to find out what x is. So we have x plus 4. We don't need the parentheses there. There's nothing in front of it. Just distribute. So we're just going to write x plus 4 plus 31 from our other angle equals 90. Okay, so now we're going to solve this one. So we've done equations like this before, but our first step is to combine any like terms that are on the same side of the equation. So 4 plus 31 is 35. And then I have x plus 35 equals 90. To cancel out the plus 35, we're going to subtract 35. We're subtracting 35 from each side. Yes, it is okay to use a calculator if you need to, but the numbers here are pretty reasonable. You don't have to use one. 10 minus 5 is 5. 8 minus 3 is 5. Our x is going to be 55 degrees. Because we're talking angle measures, you do want to make sure that you have a degree sign on your label, as your label. All right, go ahead and pause the video and try these three on your own. All right, so let's go ahead and check our answers. So number 1, these two share a side. That's going to make them adjacent. They are on the same straight line, and a straight line has a total of 180 degrees. Straight line is 180 degrees. So for our equation, we're going to do x plus 85 equals 180. Now we're going to solve it. We're going to subtract 85. All right, and we're going to get x equals 95. Don't forget about the degrees. Yes, you do need to show your work. If you want to just write the 180 minus 85 part, that's fine. You don't have to write it all out in equation form if you don't want to. But I'm going to, because as our answers are going to get more complex, it's going to be easier for you if you have an equation. So you're always going to see me write one. You don't have to write an equation, but you do have to show your work for however you do the problem. All right, let's take a look at number 2. X is diagonal from this one. That makes it a vertical angle. Okay, and then because I know they're equal, and I know a little right angle, that corner there is going to equal 90 degrees. Then I have x equals 90 degrees. All right, let's take a look at number 3. Number 3, they're touching. They've got a shared side, so they're going to be adjacent. Okay, that little right angle tells me together they're going to equal 90 degrees. So I'm going to write my equation 2x minus 1. Oops, I started to write a plus, so I'm just going to go ahead and do a boom boom over here so I don't have to erase. 2x plus negative 1 plus 69 is equal to 90. Negative 1 plus 69 is 68. So now I have 2x plus 68 equals 90. Next step, I'm going to subtract 68 from both sides. All right, and let's see, I have 2x equals, go ahead and borrow here. All right, 10 minus 8 is 2. 8 minus 6 is 2, so I have 2x equals 22. And then I'm going to divide by 2. Almost ran out of room here. X equals 11 degrees. Don't forget about that degree symbol on your answer. All right, so our next type of problem is looking at how to draw vertical angles or draw a type of angle using a protractor. So if you don't have a protractor right now, go ahead and pause the video and find a protractor. Okay, so hopefully now you have a protractor and you have a piece of paper. It's important that you do this along with me so that you understand what to do. Okay, so here's what we're going to do. It says draw a pair of vertical angles with a measure of 40 degrees. So for our angle constructions, we're going to go ahead and use the bottom of our protractor like a ruler, and we're going to draw a nice neat straight line. Now unfortunately for me, I can't actually press up against that ruler, so it makes it a little bit more difficult for me to draw a perfectly straight line. On your protractor, you should be able to use that bottom edge like a ruler to draw a nice straight line. Okay, let's see, is this gonna work for me? Okay, great. So then the next thing you need to do is pick a point on your line, and whoops, I almost forgot, lines have arrows on the ends to show that it goes on forever. So add some arrows to the ends, and then you're going to pick a point in the middle, be your center point. Go ahead and put a point in the middle of your line. Now you're going to take the center point of your protractor. A lot of protractors have a little hole here. Some don't. Some are like mine that don't have a hole, but you can see where it kind of crosses. It's not down here on the bottom where the ruler is. For most of them, it's a little bit up. So find that hole, and you're going to line up that hole right on top of the line that you just made. Now we're going to find 40 degrees. So we are going to, you can use either the top side of the numbers or the bottom side of the numbers. Whatever side you want your angle to be on, you look at to see where the 0 is. So if I want my angle to be on the right side, and generally I do make my angles to the right side, then I'm using the bottom set of numbers. So we find where 40 is on the bottom set of numbers, and then I just move out to the edge of my protractor and I make a little point. Now if your protractor has a hole here, you can make your point right here, but mine doesn't have a hole there, so I've got to kind of trace out to the top. Okay, so our next step is to line up the 2 points that you have. This point here in the middle and this point that you've drawn there. Now with your protractor, whoa, that isn't too bad for you to do. On mine, on my computer, it's a little bit harder. And I'm going to do the best I can to get it to line up. No. Okay, so I've got my point on one edge, I've got my other point on the other edge. So now you're going to draw a straight line. Again, you're going to use the edge of your protractor really nice and straight. And you're going to draw it all the way through because we need vertical angles. We need a pair. That means 2 vertical angles. Then we're going to make some arrows on the ends here to show that they're lines. anything they ask you to draw, and we're going to do lots of constructions with protractors on in this chapter. Anything they tell you to draw, you have to label. Our vertical angles, this was one, 40 degrees. My other vertical angle is across from it, 40 degrees. If yours doesn't look exactly like mine, rewind the video a little bit and try it again. What you are not doing is making a mark at 40 and making a mark at 40 and saying that's my vertical angles. That's not going to give you vertical angles. You need to do one line flat and the other one at 40 degrees. All right. Let's go ahead and try this next one. Pause the video. Try it on your own. Okay, so let's go ahead and try this one. Again, first step, we're going to use the bottom of our protractor to draw a nice, neat, straight line. Then you're going to draw some arrows on the ends of your lines and pick a point to be your middle point. The next thing you need to do is to line up the center point of your protractor with the center point of the line that you drew. Don't put it on top like this. You need to put your center little hole or the little cross part in the middle right on top of where you put your dot on your line. 75 degrees, I'm going to use the bottom set of numbers because I'm going to draw my angle to the right. If I wanted to draw my angle to the left, then I'd use the top set of numbers. Going to the right, we're always going to use the bottom set of numbers. Here's 70. 75 would be halfway in between 80 and 70. If you have an opening down here, you can mark it there. I don't, so I'm going to have to trace it up to where it would be on the top. Then you're going to move your protractor so that the straight edge is touching both your new point and your original point. All right. I can't press up against mine, so mine isn't perfectly straight. You can press up against yours, so yours will look a little bit better than mine. I just kind of have to free draw that straight line. Arrows on the ends here. 75 degrees. 75 degrees. Always a good idea to at least look at your angle measures and see if it makes sense. 90 degrees is a right angle. It would be straight up and down. 75 degrees is less. So you should have something that looks like less than a right angle. If I did my 75 over here, then I should be able to look at this and go, oh wait, that looks like it's more than a right angle. All right, so let's take a look at our next type of problem. So all of that was 7.1, focusing on vertical and adjacent angles. In 7.2, we look at complementary and supplementary angles. It's very, very similar to what we did in the first half, which is why we are doing these two lessons combined. So for complementary angles, two angles are complementary when their sum equals 90 degrees. So sometimes you see them separate like this, 30 and 60, and you just have to add them and say, yep, I know it's 90. Sometimes you'll see them adjacent, touching each other, and then you'll see a little right angle. And we saw ones like this earlier in our 7.1 notes. Two angles are supplementary when the sum of their angle measures is 180 degrees. So sometimes they're separate and we have to add them together to see. Sometimes they're touching and you can just see that they form a straight line together. So complementary, when I'm thinking about complementary, sometimes something that helps me is to think of the word corner. Corner, 90 degrees, complementary, and corner both start with the same letter. And then supplementary, I think of a straight line. And straight line and supplementary both start with S. So if I see a corner, 90 degrees, when they're together, that's complementary. If I see a straight line when they're together, it's supplementary. All right, so let's go ahead and look at this. Tell whether the angles are complementary, supplementary, or neither. So you might be able to do the math in your head, but I want to see the work for what you're doing. So that work would look like this. 70 plus 110 equals 180. They equal 180. So they're going to be, oh my goodness, why am I writing the wrong thing? They're going to be supplementary. If you push them together, they would make a straight line. Supplementary, straight line, 180. Okay, for B, I'm going to add 41 plus 49 equals 90. 90 degrees, complementary. All right, so if I look at my bottom one here, hopefully you can see, well, it doesn't look like a straight line, and it also doesn't really look like a 90-degree angle. So it kind of looks like neither, but we're still going to do the work to support our answer. 8 plus 2 is 10. So I have 3 and 6 is 9. I have 190, so that one's going to be neither. Don't just look at it and say, yep, it's neither. It doesn't look like a straight line or a 90-degree angle. You need to support that with math. So our next type of problem is saying if it's complementary or supplementary, and then finding the value of x. So now this time I don't have neither as an option. It's got to be one of these two things. Complementary corner, 90 degrees. So this first one is complementary. When I set up my equations, we saw ones just like this earlier with our adjacent angles. These happen to be both adjacent and complementary because they do share a side. We're going to set up our equation to equal 90 because it's a right angle. Now we're ready to solve. So we're going to start by subtracting 36. We're getting rid of the addition first. Okay, 90 minus 36 is going to give us 54. We have a times 4 here, so we're going to divide by 4. Right, and then when we do 54 and we divide by 4, we are going to get 13 and a half. It's okay to have a half of a degree. It's not always going to be a whole number. All right, let's take a look at B. Here I can see the two together form a straight line, so that's going to be supplementary. All right. So they're going to equal 180 together. So we have x for the first one, x minus 4 for the second one. And then they're going to equal 180 because they're supplementary. We're going to start with boom boom, and then we're going to combine our like terms. X plus x is 2x plus negative 4 equals 180. I'm going to get rid of the minus 4 by adding 4. So I have 2x equals 184. And then I cancel out the times 2 by dividing by 2. All right, and then when I do 184 divided by 2, I get 92 degrees. All right, let's take a look at this next one. Again, I want you to grab your protractor and do this with me. So find that protractor. Hopefully it hasn't gone far from the last time we used it earlier in this video. Draw a pair of adjacent supplementary angles so that one angle has a measure of 60 degrees. Supplementary means they're going to total 180. Adjacent means I'm going to label two angles that are next to each other. All right, so I'm going to use the bottom of my protractor. I'm going to start this one like I have the other ones that we've done so far. I'm going to trace the line at the bottom. Nice, neat, straight. add some arrows on the ends, pick a point in the middle. So far, all of that is exactly like what we did when we did our vertical angles. Now I need one of them to have an angle measure of 60 degrees. So I'm going to line up that center point. Remember, it's not down here. It's wherever the little hole is on your protractor or wherever the little cross is on your protractor. Sometimes it's at the very bottom, but most of the time it's not. Okay, and so now I need 60 degrees. I'm going to use the ones on the bottom because I want to make my angle to the right. I'm going to go up to the top. I'm going to make a point where that is. And then I'm going to, whoa. I don't want random lines. Oh yeah, no, my protractor, I forgot. It won't let me erase my lines. Because it's kind of weird like that. Okay, so, that's all right. I'm going to ignore the random line that I drew. You want to line up your center point here with the point that's the edge of your protractor, or I mean that we made from the edge of our protractor. And we're going to trace it, but unlike the last time where we drew it all the way through, we're going to stop when we get to that point. Stop right there. We're not doing vertical angles that are diagonal. We're going to do adjacent angles that are next to each other. And we're going to make that into an arrow. 60 degrees. Now it says I need the pair, so I need the other number that's going to equal 180 when it's added to 60. So I can do, if I'm not sure what that is off the top of my head, I can do the work to show that. It's going to be 120. Now if I use my top set of numbers when I drew my first angle, I went over here, then that would mean my 60 degree one would be on the left. The 120 degree angle should look bigger than your 60 degree angle. If it doesn't, then you did something incorrectly. All right, go ahead and pause the video and try these two on your own. All right, so let's go ahead and check these. First thing we need to do is label complementary or supplementary. So number 5, that's supplementary. They form a straight line. Okay, so when I write my equation, I've got 4x plus 5 plus 41 equals 180. I need to combine my like terms that are on the same side of the equation. 5 plus 41 is 46. So I have 4x plus 46 equals 180. Next step I'm going to do is subtract 46 from both sides. So then I have 4x equals, and then that's going to be 134. And then my last step here is going to be to divide by 4. Oh, okay. And when I do 134 divided by 4, I get 33.5. degrees. All right, let's look at number 6. Number 6 forms a right angle. I can see that little square in the corner, complementary corner. So these are complementary. That means my equation is going to equal 90. X plus 2x minus 3 equals 90. Got to combine my like terms that are on the same side of the equation. So I have 3x minus 3 equals 90. I'm going to get rid of the minus 3 by adding 3. So I have 3x equals 93. And then I get rid of that times 3 by dividing by 3. I get x equals 31 degrees. All right, next one, number 7. Go ahead and pause the video. Try this one on your own. Okay, let's try this one together, or check your answer with mine. Hopefully you've already done yours. Okay, straight line. Use that protractor to make sure it's straight. Center point. Line up your protractor with the middle point here. 15 degrees. You're going to go bottom set of numbers to where 15 is, halfway between 10 and 20. Go out to the edge, make your point. Oh, man. Okay. I did not grab it in the right place, so I'm going to have to switch colors here. 15 was right here. Come on. Okay. So now I'm going to rotate my protractor. Man, it's really not liking me. I'm going to draw my line. I'm not going to go past the center point here. I don't want vertical angles. I want adjacent. I'm going to label this 15 degrees. Then I need to label the other one. To get the number that I need to subtract. When I do 180 minus 15, I get 165. So this one should be 165 degrees. Yours should look like mine with arrows on the ends of your lines. This one's really a right, not a line, since it ends at this point, but you should have an arrow at the end as well. All right, last one, true or false. Go ahead and pause the video and write down what you think for each one. All right, let's check our answers. Number 1, vertical angles are always acute. That's false. Sometimes they can be acute. Sometimes they're obtuse. Sometimes they're right. Number 2, adjacent angles could be congruent. Can they be congruent? Sure. If I have a straight line and two 90-degree angles, absolutely they can be. Are they always? No. But can they be congruent? Yes. Number 3, supplementary angles could both be acute. Acute means less than 90. I can't have two angles less than 90 that add to 180, so that one's false. Number 4, supplementary angles could be congruent. Yes, that's true. If you have a 90 degree and a 90 degree, they would be congruent and supplementary. Complementary angles sum to 180, that's false. They sum to 90. Complementary angles could be obtuse, that's also false. To equal 90, they can't be more than 90. Obtuse angle is more than 90.